Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video we're going to be solving a very nice cubic equation with complex numbers. Now I call this equation nice because the solution method I think is nice, but we're going to be looking at two different methods here. So let's start with the first method, which is usually the more painful one, okay? So we have z minus z squared minus z cubed equals 2, and we're going to solve for z values. How do you solve for z in an equation like this? First of all, this looks like a cubic equation, doesn't it? So let's go ahead and put all the terms on the same side with z cubed having a positive coefficient. In other words, the leading coefficient is positive. So that will be the right-hand side. Let's do it. Z cubed plus z squared minus z plus 2 equals 0. If you look at this hard enough, you're probably going to realize the second method. But before we get there, let's talk about the first method. Because first method, even though it's a little painful, it's kind of fun. Okay, great. I hope you agree with me on that. Let me know what you think at the end of the video, okay? Or during the video, anytime. So we have a cubic equation, so why not invoke the cubic formula? I don't want to attribute it to any person because there's a lot of, discussion like who invented it first, doesn't really matter. We have a formula, that's what matters. So here's how the formula works. We have this identity, that's something that I constantly use in algebra for factoring. A lot of identities are based upon this, which is really nice, by the way. But if in this equation you kind of call this z, you get a cubic equation in z, something like this. And by comparing it to any cubic, we can pretty much solve this, because you know why? Because this turns into, eventually you're going to see it, a quadratic equation. First, it turns into a system and then turns into a quadratic equation in a single variable, which we can solve to find the values of a and b, which we can use to find the value of z, because z is equal to a plus b. Does that make sense? That's the cubic formula in a nutshell. I hope that makes sense. Now, let's go ahead and see how we can use it. But the only problem we have, it's a huge problem by the way, is we have a z squared, but this doesn't have z squared, because you do need a depressed cubic. Your cubic must be very depressed, right? A depressed cubic to be able to solve it, because this cubic cannot be solved. I mean, it can be solved by other means, but not with the cubic formula directly. So we need to get rid of z squared. How do you do that? By doing a little bit of hocus pocus, some incantations, doing a little bit of math magic. Let's try some magic or mathematic here, okay? Here's how it works. You look at the coefficient of z squared, it's 1. You take the 1 and divide by the degree, which is 3. You put a minus sign, and then you put another variable like y in front of the number that you obtained, and set it equal to z. I hope this made sense. And that's your substitution. This substitution will get rid of the square term. I'm not saying z squared because you're going to end up with y squared, but y squared will be poof, gone. Okay, makes sense? Let's do it. It's fun. Now we're going to do y minus 1 over 3 to the third power plus y minus 1 over 3 to the second power minus y minus a lot of manipulations. But get used to this, because a lot of times we have to deal with fractions. I know they're kind of annoying. For this one, I'm going to use my identity. That is very similar to this, by the way, just for a minus b cubed. I meant this one. Okay. Anyways, same idea. So I'm going to write this as y cubed minus 1 over 27 minus 3 times that, which is y, multiply y minus, I don't know. I've just gotten used to writing it that way. This one is y squared minus 2 over 3y plus 1/9, and the minus y plus 1/3 plus 2 equals 0. Beautiful. Now we're going to get the following. Y cubed minus 1 over 27 minus y squared plus 1 over 3y plus y squared minus 2 over 3y plus 1/9. That's a lot of terms, right? Plus 1/3 plus 2 equals 0. It's kind of like an endurance test, right? How far can you go? So now y squared cancels out. Yes, that was the goal. We want to get rid of the quadratic and make it a depressed cubic. This is y cubed. And then we're going to have, let's see, 1/3 minus 2/3 y is going to give me negative 1/3. And negative 1/3 minus 1 is going to be negative 4/3 y. And then finally, we have 1/9 plus 1/3 plus 2. That will be 3/9, 4/9, and then 18/9, 22/9, if I didn't make any mistakes. Of course, I do need a constant on the other side, but first I had to combine like terms. And now we can go ahead and just put it on the other side, and this will hopefully be in the form that we want. Of course, we're going to need to arrange this with z or y, but you can kind of write it like this. Okay, let me rewrite that so you can see what that looks like. A plus b cubed minus 3ab times a plus b equals a cubed. Get used to writing this because this is basically the essence of cubic formula. And now it's pretty easy, right? I mean, you don't really need to memorize it. It's only this identity you need to know. Now, if you call this y, and now we're going to get our equation y cubed minus 3aby equals the constant. Now we're going to compare these two equations, and then we realize, the coefficient of y is negative 4/3, but that's the same thing as negative 3ab. So 3ab must be 4/3, which means ab must be 4/9. And then the a cubed plus b cubed is supposed to equal that nice number, not so nice number, but let's just pretend it is negative 22/9. Now this is our system, and guess what? This is quadratic, not cubic, because if you cube both sides here, you get a cubed b cubed equals 64/729. Is that the cube of 9? I believe so. And then a cubed plus b cubed is there. So what we can do is we can actually isolate b cubed from here and write it as negative 2/2/9 minus a cubed. And then this can be substituted here. Ta-da, a lot of substitution. Isn't that fun? So a cubed and b cubed equals this. And now we're going to make one more substitution, which is calling a cubed something, because we're going to get an a cubed 6. Let's call this c. So now we get c squared. Put everything on the right-hand side. C squared plus 22/9c plus 64/729 equals 0. And ta-da! This is a quadratic equation, like I told you earlier, right? And then from here, you can hopefully find the values of c. How? With the quadratic formula, negative b plus minus the square root of b squared. I think 22 squared is 484/81 minus 4ac. 4 times 64 is going to be 256. And that is going to be divided by that. And this will definitely be a positive number, which is good. Now, you can make a common denominator, multiply by 9, multiply by 9. That's going to be like something in the, who knows, like 4,000 something. Subtract 256, and you see, that's a lot of work. It's crazy, right? That's why the first method is almost always just crazy and almost undoable, super painful. But hopefully it was helpful. It taught you something. Anyways, let's go ahead and talk about the second method, because that was my ultimate goal. Can't even write that 3. Let's put everything on the same side one more time, but this time we're going to be super smart. How? By looking at the patterns. This is a problem from a math competition or something like that. So we need to find something elegant, right? And here's how we do it. We realize that, z squared minus z, if we had a plus 1, that will be part of an expansion, which is called sum of two cubes. We have a cube. Nice, super duper exciting. So here's what we're going to do. We're going to split up the 2 into 1 plus 1. So now we can write this as z cubed plus 1 plus z squared minus z plus 1 equals 0. And that does the magic. How? With a little bit of math magic, we're going to get the solutions. Here we go. Okay, now z squared minus z plus 1 is a solution, and is a factor, I meant. Plus 1 is 2. And now from here, we immediately get z equals negative 2, right? So another approach would definitely be looking at the rational root theorem. Factors of 2, come on, there aren't that many. There's only 4 candidates. Plug it in and you'll find negative 2, and then reduce the degree by division. But how would you find that? After division, you would find it. What are the solutions? Since this comes from a sum of 2 cubes, which is z cubed plus 1, they're going to be the cube roots of identity, like e to the power 2 pi and I. I meant not the roots of identity, the roots of negative 1. So in other words, e to the power I times pi plus 2 pi n. But one thing to keep in mind is negative 1 is not a solution. So you have to exclude n equals 0 and go with these values. All right? I don't think I included anything. I forgot probably, but anyways, forgive me for that. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.